polygons, what we said really, and then we did similar figures and focused on polygon between straight sides. What were the requirements? Again, just think of a triangle if that's the one we did the most. What were the requirements for those polygons to be similar? Well, what specifically about them? Corresponding angles could prove it, but why was the fact that they were corresponding important? What is true about corresponding angles? They are what? No, they're not similar. They're, first of all, two angles can't be similar. They are, what's the measure of two corresponding angles? Like, they are what? Well, you won't know a number, but they are what? Like they're different numbers, but they're always going to be what? Congruent. They're always the same. So the first requirement is the angles are the same. So if you got a triangle, all the angles will be the same measure in the triangle. Okay. What was the other requirement? Yeah, same proportion between the sides, same scale factor. Those were the two requirements. What was the real definition, though? Like, that was how we proved them. But before that, there was even a definition that we used. You might remember, like, I'll give you a hint. We had to do kind of when we did transformations. And we said, oh, well, if we can take one shape and move it around and it lands exactly on top. We flip it. So we did rotations, reflections, translations, and we said, if we can take this, could be any shape, I'll say triangle. We can take this triangle, flip it, rotate it, slide it, and it lands exactly on this other triangle. It's congruent. That's the definition of congruent. So what was the only thing we added in for similar figures? Two shapes were similar if we did what? What was the other transformation you learned?
Dilation.
So we learned a dilation, right? We learned, well, what if they're not congruent? Like we can clearly see one is bigger than the other one, so they're not congruent. We know that. But man, they really look like they're the same shape. They look like they're kind of the same triangle. We said, well, if we can take one of the triangles and enlarge it or reduce it, depending on which one we start with, and then once we enlarge it and reduce it, then we move it around and it lands right on top. That was the definition of similar. We just had to change in proportion, change the size of one of them, and then see if we could have it land on top. So now, moving into our lesson for today, we have two circles. Are they similar? Why? Technically not really a scale factor in circles, but using that concept, what would be true? What's the only real measure of a circle? They do always have 360, so that's kind of like if you're using that concept of the angles are the same, they do all have 360 degrees, so that kind of still matches up. What's the only measure really of how big a circle is? Well, circumference is, but what do we use to get circumference? Say again. Radius. We really just only have the radius. That's all. That's the only measurement a circle has. Now, we use diameter, we use circumference, but we're using radius to find all of it. We're multiplying it by 2 to get the diameter. We're putting it in the formula for circumference, which again, if you weren't in here, that's going to be your exit ticket. So circumference really is 2 times pi times r. That's the main, that's the formula. We can just convert that into dr because when we multiply 2 times the radius, that gives us the diameter. So really the only measurement of a circle is the radius. That's all we can change. So if they're always 360, the sides are basically, there's not really sides. We just have a radius. So there's not multiple proportions we can even create. Anytime I create a circle, I can enlarge or reduce that circle enough and have it land right on top of another circle. There's no time you can't. So, again, here's the moral of the story. All circles are similar. Every single circle. Or congruent, which is still, you can still say they're similar. So what would make them congruent? Like when would you say, what is the situation when they're congruent? If they're all similar, which two would be congruent? What would you have to have? When would we be able to say, yes, those two circles are congruent? Not just similar, because they're all similar. Not the same angle, because they're all 360, right? So something has to be the same. What's the only other measure we said we use? It's in that formula right there. Radius. Yeah, I was just about to move on. If you have the same radius, then they're congruent. If you don't have the same radius, then they're similar. That's the whole thing for circles and similarity and congruence. Same radius, congruent, different radius, similar. No other options for circles. That was what we didn't finish up. Yeah, that was what we didn't finish up the other day. Yeah, here that I said we need to finish. So again, same radius congruent, different radius, then they're still similar. There was concentric. We didn't go over that either. I don't know what the district could do with that, but concentric just means you have like a circle in a circle. They're on the same plane. So if I have a flat circle, what happened to grab what I did before? Well, I have this circle right here, we'll say. And so I have this circle right here, flat circle. If I took a pen and drew a circle, so now I got another circle, and they share those points that I drew here in the middle, they would like be on the same plane. Like if you looked at it this way, you would only see one circle, your one edge, but you can't see the other circle because they're right on the same plane. That's all concentric. Like one circle's inside, but you do have to understand they're on the same plane. Either of them is tilted at a different angle. That's concentric. And then we didn't do this. I mean, you were supposed to do it, but we didn't go over it. This problem right here, I'm going to redraw that real quickly. I think that's the best way to do it. So if you're going to kind of give me the measurements because I'm not going to go back and forth. So I got two circles. They kind of overlap. Circle tool and make it pretty close. Was the little circle on the right or the left? Little circle was on the right. The little one was? Oh. So turn to this page. Everybody, like, don't just sit there. Turn to the page. This is a question on your quiz. I told you that the other day. I remember that shape. It is on your quiz. Little circles on the right. We'll draw the little circle a little bit. There we go. So something like that. I'll even make the overlap a little bit easier to see. And then it said this. I had kind of like, I got to draw. I'll just do it by hand. It's not going to be perfect. So something like here, something like here. And then it had a line that connected those. What was the center of the big circle on the left? What was the letter? Well, the letter J. What's the letter for this K? I think I remember K, right? What do we have here? B is in boy. D is in dog. And what do we have here? E is in egg. All right. And is that all the letters? All right. So now they're saying, and this would be, I don't know if they put the actual points, but these are points on the circle. So they say, what information do they give us? J something. Circle J is a diameter of 20, right? That's a horrible circle this time. So circle J, diameter equals 20. Circle K, diameter equals 12. So here's what I would suggest. I wouldn't read anything. And again, remember, they solve it out for you. So don't look at what they've done. That's all you get in the problem. The image and then that. I would just start filling stuff in. Like, all right, I know the diameter, and that's why drawing it larger than what's on your quiz or your EOC or whatever is very helpful. Because now you have way more room. I would say, all right, well, if I know circle J has a diameter of 20, that red line is 20. And somehow you have to understand which number goes with which line. Color pencils would work great for that in my class, but you won't have that on the EOC. So the red line is 20. Oh, wait, I'm sorry. Wait, is that right? Did I just do that right? Did I? You sure I did it right? Yeah, I didn't draw in the diameter, right? That's 20. So remember, be careful. Like, don't just put the number on what you think you need. Make sure you are using the information they're giving you and correctly putting it in. So the diameter of J is 20. So now from that, what can I fill in? If I know the diameter is 20, what's that green line? That's where I write the 10. That's 10. Now they tell me the diameter of K, 12. Write that up there. So what else can I fill in there? So the radius of that would be half. Oh, I'm running out of colors. There we go. Okay. So that is 6. Oh, wait, it's hard to see that. Oh, I can write that in black. So there. So that line is 6. Now I'm not still not going to read the question. Let's see if I can figure some stuff out. Oh, wait, there's one more thing that they give you too. What else do they tell you? JD. Again, I go to a different color. You asked for it, you got it. Right, pink, hot pink. So pink is from J. Oh, I didn't hit OK. So D would be this here. 8. All right. So now let's just look and see where I can solve. I could put a 10 out here on this red section if I wanted. So again, I would. I'm not even going to read what they wrote. So that's 10 out there. That would be from J to the edge. Again, if there's not a point out there, though you're not going to use it. You're definitely going to be doing it between points because those are the line segments, but I'll still write it in. So I know from J to D. I know from J to E, right? Because from J to E is the radius. What about from D to E? Because I know this is 10, right? I know this is 8. I just subtracted. That's 2. So from D to E is 2. I already know from D to E is 6, right? Oh, so I mean, you can write, it'd probably be a good idea to keep it straight and do some of this over here too. J, what is that? JE equals 10. But again, it gets even the big picture, it still gets a little confusing. There's this 10 and this 2. You got to know which one the 10 is and the 2 is. Hopefully that fact that that's 8 tells you that the 10 has to be the whole thing. So from J to D is 8. The bigger you write the figure, the more you can like use different colors, the better off. So if this is 2 and if I know the yellow is 6, what would be from, I kind of drew it out of proportion, but that's fine. So what would that little section be right there? Yeah, so I would say, well, if this whole thing is 6, that's supposed to be a little section of 2. That would have to be 4. So what would that be? EK would be 4. So I've filled in a bunch of information. There might be, oh, I could have said over here, this is 6 also. If this is 6, this blue is 6. So the 12 actually goes from here to here. Now I can read the problem and see what it asked for. They gave it to you. They just gave that in the problem. Like it's the last thing I think in the problem. Yeah, you wouldn't be able to do it. If they did not give you that, you wouldn't be able to start the problem off. You needed that one extra piece. So if I now read the problem, odds are pretty good if I've done everything that you can do. One of them is just going to be the answer. So it's not like you're doing a bunch of extra work. Sometimes you might do something that you don't need, like this 10 over here. I'm not going to need that. But I needed to do everything. So what did they ask for in the problem? EK, right? So EK I'd already solved for. I don't need to do any more math. I already did it. I just pull it off of my. So I would just start because I see a lot of kids try to jump straight to, okay, how do I get EK? And they're missing all this stuff. And they like, I have no idea how to get there. So just instead of jumping to the end and trying to figure out what to do, just start doing what you know. Start filling in as many, because in high school geometry, they're not going to force you to solve for stuff that you might need. Like probably in middle school, they did. They would walk you through solving for each piece and say, well, what is this piece? What is this piece? They're not going to do that in high school. But just start solving for everything you can solve. And then once you think you've done everything, read the problem and see if maybe you've already solved it, or if now maybe you have enough information to solve whatever they ask you. Figures can get confusing. That's why I say if you can draw a bigger picture of it, even if you got to draw it on a whole piece of paper or something, it'll help keep it a little bit straighter. All right, so that was that problem. There are some practice so here are your practice problems, speaking of which. Oh, yeah, wrong picture. Backwards. There we go. So the additional problems, we already assigned 193, 1 through 15. Now, and this is for my class, my quizzes, 194 you're going to do. And that's basically the whole page, but up to 32. So what would that be? 16 through 32. So you're doing that for my class. I'll tell you right now, I could see the EOC having stuff like that. I'm not going to assign it. I won't put anything like that from this chapter. We'll do some of that later in other chapters. But if you want to try to take a shot at it, page 195, I think those are pretty good questions. Like I said, you will see some stuff like that later in another chapter. I will quiz you on stuff like that. So if you just want to go ahead and try them, certainly not a horrible idea. Let me lock that in real quick. There we go. All right. So now we got to do the new chapter. So turn now to the next lesson, 10-2, 199. Yes, sir. What did I just say? 199? Is that what I just said? Yeah. 199. All right. So quickly, let's see how much you know, how much you retain. I mean, we talked about a lot of stuff. How many degrees in a circle? 360, right? If I take an angle, so it's a zero. You got basically just a line on a line. That's zero. We said, okay, well, I know that's 90. Well, if I add two of those together and get a straight line, I'm at 180. Well, if I kept going, which we really haven't done, if I kept increasing it, we can actually make an angle bigger than 180. So I add another 90, that angle, and when I say that angle, I'm talking about this out here, that would be 270. And I can keep going and finish, and now the line's back on top of the other line. So another 90 is 360. So we're familiar with the fact that a circle has 360. Hopefully now you get it, you remember it. Technically, we will do some stuff where they have measurements of greater than 360s. We might actually get to that. I think we do get something like that where you'll solve A circle itself only has 360, but you might have an angle. It's not technically really an angle at that point, I don't believe, but when we get to it, we'll talk about it more. So here's the first thing you need to know, definition. If I create an angle and the vertex is the center of the circle, we talked about center of a circle, that's the way it's named. So this is the angle, right? And the lines can extend on out as they do all the way out to the circle. So that's the angle I'm talking about. That is called a central angle. I will use these terms a lot, so you've got to know, and there's going to be a lot of other ones I add in, so you've got to be able to keep them straight. So your central angle means the vertex is the center of the circle. So an angle in a circle can be made up of degrees. That angle is made up of some number of degrees. 1 degree would be a super small angle, and there would be 360 of those teeny tiny angles because there's a total of 360. So the measures of the angle match up with the measure of degrees of the circle. So the way we match that up, yes, sir. Yeah, I don't know. There's not. So we'll have to. Oh wait. Yeah, I don't see a 16, so we'll have to get you caught up when hopefully she gets back. We're not doing a whole lot, luckily, today. Okay. So for now, can you take notes on what I say without it? Like even just the words, like you type enough to take some of the stuff down that I say. All right, why don't we do that today? And like I said, I talked to Miss Davis, and she said, "Yeah, absolutely, we can figure out a way for you to come in sometime 33rd." So we'll get you caught up somehow during some of my planning periods. But yeah, there's not one that says 16, which would be the next one you would need. All right, so this number of degrees here would match the number of degrees of the circle it takes. And I'll show you how we show that in a second. So what would you just estimate? What would you say that number of degrees is for that angle? We talked about how to estimate. That red angle I got right there. Or the one in the book. It's in your book. Yeah. Got to be more than 45 because what angle did I say to start with? What kind of angle? So then go from there to figure it. Yeah, start with a right angle, right? So if I took this angle here, I think am I zoomed all the way in? Oh no, here we go. I'll zoom in a little more. So if I took that angle, I said, well, is that a right angle? Well, no, that's a little bigger than a right angle, right? So I could even kind of draw in what I think a right angle is. So that's pretty close to a right angle. So it's bigger than that by a little bit, not a ton. So bigger than 90, I would say 95 to 100, maybe. I'm just going to choose 100 just because. So I would say, based on just my estimate, I think that's about a 100 degree. So here's the next thing you need to know. The measure of the arc. So this is called an arc. So I told you there's going to be some new definitions. Here's another one. That is an arc. All an arc is a curved line segment. It's part of a circle. It's always going to be part of a circle. At least with what we do, it's part of a circle. So the measure and the way we write an arc, kind of like a line segment, 2 letters, but then instead of a straight line, just a curve. Is it a curve? Line. Or a circle. So the measure of an arc can be done in 2 ways. We can do it using a length. Like if we took a piece of string and we laid the string exactly on that red, So we just mapped out using a piece of string that arc. Then we took it off of the arc and we straightened it out and measured it with a ruler. We can measure the arc that way. So centimeters, inches, whatever you want to measure it, millimeters. Or we can measure it in degrees. That's another way you can do it. We can say how many degrees is that arc, which is more like a percentage kind of thing, like how much of the circle is it taking up. 100 degrees of that circle would look similar to 100 degrees of that circle. So this arc here would also be 100 degrees. Oh, so the arc matches the central angle, by the way. So if that's 100 degrees in the angle, then the arc is also 100 degrees. The angle, the central angle, make sure you write central. Don't just write angle. We're going to learn other angles. Don't match. So the central angle, and it's down here, so we're going to get to it. The central angle, the measure of the central angle matches the measure of the arc that has those same endpoints. Arc that's inside the angle, however you want to write it. Or draw pictures is a good way. So this 100 matches that 100. So again, this angle in here is 100 and this arc is 100. I can't really, I guess I could do two arrows sort of. But clearly they're different sizes, right? They're not the same length. So degrees is more like a percentage of the circle, like how much of the circle does it take up? That way it doesn't matter how big or small the circle is, they're still taking up the same percentage. This is taking up a little bit more than 1/4 of the circle. Well, so is this. This takes up a little bit more than 1/4, even though they're totally different lengths. If we were to try to measure out, string that would be the same length. How many degrees in an arc that is a semicircle? Alyssa. Yeah, it's half a circle, right? So if I drew, I'll just draw one through here. If I drew a diameter in, right? Because diameter is splitting the circle into two halves. So now I have an arc right there, right? That is half the circle. That's what a semicircle is. If you didn't know that, that's a definition here too. Semicircle is half the circle. Well, if a whole circle is 360, then the arc that is highlighted in yellow would be 180. It's half the circle. So what would the central angle be if I created an angle and called it angle EBD? How many degrees in angle EBD? How? How many degrees in that angle? Yeah, it's still 180. It's a straight line. It's confusing, right? But it gets confusing in circles. A straight line, we said before, is always 180, right? Because basically I can do that same arc thing. That's how we did it, right? We drew a line when we did angles and said if I can draw a semicircle, then the line is a straight line. It has 180 degrees. So it kind of goes back to why we used a semicircle. It's because if a full circle is 360, then half a circle is 180. So that's why a line is 180 degrees. So again, the central angle is 180 and the arc is 180. They match up. That's the biggest concept from today that'll be on your quiz Monday is that central angle and arc match up. And then the fact, so none of this should be super complex. If we have a circle, again, how many total degrees in a circle? So therefore, if we think of it as one big angle, how many degrees in the one big angle? We went all the way around until we got back to the beginning. Also 360, right? That's a central angle. So if I split that into multiple angles, what's true about angle 1, 2, and 3? They have to add up to 360. That's the same thing we did in little plus little is big. You take one big angle and you split it up, all those little angles have to add up to whatever that one big angle is. And that's all they're telling you right there. That's that concept there. Let me ask you this question. Conceptual thing, but also going to be a definition. So here's A, make it smaller this time. A and B. And we'll say the center. Let me try to do a better job of this than just completely guessing. That's all right. There's the center. I want you to estimate quickly. What do you think that angle would be? I'm sorry, the arc. Kind of gave away, but what would arc AB measure in degrees? Think about it on your own. I'm going to kind of give you a little help. I'm going to help you cheat a little, or not cheat, but help you estimate. Right? That would be the angle. What am I going to call on for this? Nadlin. What do you think the measure of that angle is? So angle first. So definitely less than 90, right? So if I really wanted to, I could get specific and try to divide it into 45 and 45 and figure it out. So let's say, just to make the number easy, let's just say 60. Let's say we think that's about 60, because 90 probably would be out here, and then that's maybe 2/3, 60, 65, 65, 55, whatever it is. We'll just say 60 to make it easy. So what's the measure of the arc? Definition of an arc. What's just the definition of what it is, not measuring it, right? It's the part of the circle that basically, is in between 2 points, right? So let me ask you this question. I'll use pins for this. Everybody told me what they thought that arc was, right? How'd you know I wasn't talking about this arc? It's between 2 endpoints. Right? Part of the circle between 2 endpoints, right? How in the world are we going to figure out what we're talking about? I'll give you a hint. It's on this page, right? So here's the thing you need to now understand. It's another definition thing. We have 2 arcs. If you have 2 points on the circle, you have 2 arcs. The way you name the small arc is with 2 letters. Always, like no exception. It's called a minor arc. It will always be less than 180. Exactly 180, I'm not sure. Well, it wouldn't matter. It doesn't matter which way you go. It's always 180 if it's exactly 180 either way. So the minor arc is less than 180 and named with 2 letters. So the blue line is the minor arc. Again, that would be arc AB. That would be the one that we would say is about 60 or whatever we thought it was. The major arc, the green line, you have to have a 3rd point. So somewhere on this part of the circle, they'd have to give us another point. That then tells us we're going the other direction. We're going from A to C to B, or we could start at B and go B, C, A. So that arc is the major arc and would be named like that. You have to have a 3rd point, though. If there's not a 3rd point, you assume you're talking about the minor arc, the small arc. So just the little arc between the 2 points, and that's all you have to do. So you see they did that down here. They named PSR. Oh, and then they both have to add up to 360, right? So the way you would find, if you had one, the way you would find the other is just subtract from 360, which is what they're telling you down here. So if I knew this was 60, what's the other one? What's the major arc? Yeah, we just would subtract from 360. I'll write it in green. So, and again, degrees is how we're measuring right now. We will get into measuring it in length and units. How would you say 3? Well, this is an arc, but I'm not using that arc. Yeah, you could say there's an arc between B and C too. I'm just telling you the way you name a arc larger than 180 is with 3 letters. If I named this CB, then I'd be talking about that arc. So there is actually more than 3 arcs, really, because now I could also say CA is an arc as well, so even more than 3. if I put that other point. But we're not using that one in this problem, but you could have 20 arcs even though you only have like 5 points because each section between different points is a different arc. So we got 9:05. So one quick thing, and we'll wrap it up on Monday, but you're gonna also have this on your quiz on Monday, that same thing we wrap up. So again, we talked about the fact that arcs are congruent if their angles are, or we talked about the measure of the central angle matches the arc. So if two central angles are congruent, then the two arcs are congruent as far as length goes. Where's the problem? Oh, there we go. All right, so really quickly, then we'll do the exit ticket. I want you to solve for x, but I also want you to do this. Write the measure of these arcs, and you'll notice they're all going to have 2 letters. E and D, E, I guess. So really quickly do those 3. And you're still solving for x. Right there. And we'll wrap that up. Again, you may want to try to practice a little bit of this for the quiz because what we're going to do on Monday will also be on that quiz. If you couldn't do retakes, I wouldn't do that, but you can do retakes, so I don't feel like it's super complex. I still think you'll be fine. Quiz is Monday. It's only going to be like, it's already only, if I didn't do anything else, it'd be like 3 pointless to have a quiz. So we're going to still put it on there, and then if you need to do retakes, you can do retakes. I think most people will pick it up enough where they'll be fine. Hopefully. So I'll give you another minute, and we got to do the exit ticket. We'll just fill those in really quickly. Leaving town. You might want to go the other way. Yeah, there we go. Keep going. All right, what is arc CD? Come back this way. There you go. So you're about to get a table and then desk. Watch out right there. There you go. Going. Keep coming this way. CD is what? Yeah, it just matches the angle, right? There you go. What is BE? Again, that all you had to understand is there was a right angle symbol in there, right? Right angle symbol at 90. All right, so yeah, we'll talk to her. Remind me when we see her Monday. We need to catch you up on wherever that book is. So, all right. Have a good weekend. So, what else I do? DE. What do I need to do for DE? Just DE. We have them all. So if I want, oh, I'm sorry. Right. Yeah, good point. I actually meant the big D. So what is DE then? But what I still need to do this other thing. What do I need to do to find X? Yeah, I need to add all of these up, right? So I think that's 215, and then do what? Yeah, 360. So you should have gotten for X, you get 145, which means for DE, you also get 140. All right, so go ahead and put all that stuff up. I'm going to give you this as quickly as I can and get started. Luckily, this So this is circumference. I'll give you the formulas in a second. I know you can get started. Wait, C equals dr. If you already have one, you can write down. So C equals dr or C equals 2 pi. I'm sorry. C equals d pi or C equals 2 pi r. I'll write them up. Don't. I got one. So don't have a calculator. I mean, it should be plenty around you. Last class is big clouds. Anybody not have one to reach? Oh, Zoe. Here. Today we did that last class. Basically, just plugging something in formula and phone. Got a couple minutes, but should be plenty of time. I think you're solving for it. I'm sure you're solving for something else. You're solving for whatever it said to solve for. They gave you the information within the formula, but not the radius. You just got to plug it in the right spot and you solve for whatever the variable is that's missing. What number is it?